Crystallization video part 3. Now in this part we will learn how to grow crystals of our samples. We have completed part 1 of the background on crystals and their importance in everyday life, and part 2 dissolving and saturating our samples. And we have seen that the 5 samples such as table salt, sugar, Epsom salts, alum and potassium nitrate, as shown on the screen, have very different properties. So now, in this experiment, we will be making a saturated solution at a higher temperature and then cooling it down so that some of the dissolved material comes out of the solution in crystalline form. All 5 samples, such as table salt, sugar, Epsom salts, alum and potassium nitrate, should be tested by the group. Before beginning, let's address the following questions. Do we think that the amount of sample that dissolves in hot water will be different from cold? Why? Can we predict which sample will grow the biggest crystal? The materials we require for this experiment are kettle, hot water required, needs adult supervision, potential slip or burn hazard. 2. Thermometer. 3. A container or a cup. Clear plastic disposable cups or glass beakers. The 5 samples: table salt, sugar, Epsom salts, alum, potassium nitrate. Teaspoon or spatula. Small measure. Measuring 40 cm cube is required. For example, measuring cylinder, beaker, or a clean medicine syringe. Filter paper. A thin wooden food skewer. Contamination warning: do not reuse. Potential sharp stick injury. Clothes pegs, or an alternative way of suspending the skewer in the solution. A magnifying glass to see the crystals more clearly. Now let us begin the procedure. Ask an adult to boil tap water. Into a clean container/cup. Add 4 full teaspoon measures of our sample. Ask an adult to measure 40 cm cube of the hot water. If the temperature needs to be higher than 70 degrees Celsius, transfer this to the container with the sample inside. Potential burns, spill, or cup melting hazard. We could use secondary containment to prevent burns or spills. Stir the sample for 30 seconds, and if required, add more sample repeatedly until the sample will no longer dissolve. Larger amounts than in part 2 can be added to get to saturation. Fold a square filter paper into a triangle, making 2 folds and opening it to make a cone-like shape. Pour our warm saturated sample through the cone-shaped filter into a clean, empty plastic disposable cup. This process removes the undissolved material. Using a wooden skewer and clothes pegs, suspend the tip of the skewer just below the surface of the solution. Leave the cup for a week for crystal growth. After a few hours, crystal can often be seen at the bottom of the cup, but the slower growing crystals will grow on the stick. If after a day you do not see any crystals, add a few grains of the solid sample to encourage crystal growth. After a week, record the temperature of the remaining liquid on your results table. Remove the stick and identify the biggest single crystal from your cup. Match your crystal to our size and shape charts below and record your data in the results table H and I. Collaborate with others to get the best results for all the samples. Here in the table, we can see on the first row our 5 different samples are mentioned, such as table salt, sugar, Epsom salts, alum, and potassium nitrate. And on the first column, it was given the bases depending on which we need to fill the report. 1. Names of samples. 2. Temperature of the remaining solution, your local room temperature, degree Celsius, G. The size of the biggest single crystal, H. The shape of the biggest single crystal, I. Fill the table accordingly.